All right, well, good morning, sixth graders. As we did last time, we were talking about surface area of triangular and rectangular prisms. Okay, today we're going to be getting into surface area of pyramids, and we're going to start first with a square pyramid. Now, first, to make sure that we understand, a square pyramid has a square base, and then since a square has four sides, there are four triangles that come up and meet at a point at the top. Okay? Now, since this is a square pyramid, we are going to assume that you understand that a square has four congruent sides. So, since the square has four sides, then we can come to the logical conclusion that the triangles coming up from the square pyramid are also all congruent in size, which means they have the same area. So that's a key component that helps us be a little more efficient in finding the surface area. Now remember, surface area, we're going to find the area of each of the flat faces, the flat surfaces, and then combine it all together. So a square pyramid will have one square, which is the base, and then the four triangles coming up from the four sides. So there's five different faces, and then since a square has four congruent sides, the triangles are all going to be the same size. So, first of all, it says the length of the base is 6. Well, so to find the area of the square, if the length is 6, the width is 6, so 6 times 6 is 36 square feet. The length of the area of the square would be 36, because the length is 6, the width is 6, 6 times 6 is 36. Now a triangle, remember that's going to be base times the height divided by 2. Well, the length of the base of the triangle is 6, times the height of the triangle, which is 7, that's 42. And if I take 42 and divide it by 2, 2 can go into 4 twice, 2 times 2 is 4, 4 minus 4 is 0, drop the 2, 2 can go into 2 one time, and I know there's none left over because 2 times 1 is 2. So one of the triangles has an area of 21. But since it's a square, excuse me, we know that all four sides are the same, which means that all four triangles are the same. So I can just take 21 times 4. Well, 4 times 1 is 4. 4 times 2 is 8. All four triangles combined are 84. So I bring that over here to my 36, and I'm just going to add those. 6 plus 4 is 10. Put the 0 down, carry the 1. 1 plus 3 is 4, plus 8 is 12. 120 square feet for the surface area of that square pyramid. So here's another one before we look at triangular pyramids. The length of the base is 3 2/10 meters. So if the length of the square is 3 2/10 meters, the width of the square is 3 2/10 meters, which means I've got to do 3 2/10 times 3 2/10. So 2 times 2 is 4. 2 times 3 is 6. Put the 0 down so it all lines up with my 3. 3 times 2 is 6. 3 times 3 is 9. Going to add these two numbers. 4 plus 0 is 4. 6 plus 6 is 12. Put the 2 down, carry the 1. 1 plus 9 is 10. There are 2 numbers that come after the decimal in my problem. So 2 numbers that need to come after the decimal in my answer. The area of the square is 10 24 hundredths meters squared. So for the height of the triangles, once again, there's going to be 4 of them. So it's base times height divided by 2. Well, I'm going to save a little time, and I'm going to go ahead and divide this by 2 already. So instead of multiplying it by 12, I'm going to multiply it by 6. Okay, and I'm just going to do my division by 2. It'll give me the same answer. So I'm going to come over here and do 3 2/10 times 6. Well, 6 times 2 is 12. Put the 2 down, carry the 1. 6 times 3 is 18, plus 1 is 19. 1 digit after the decimal in the problem, so 1 digit after the decimal in the answer. But I have 4 congruent triangles. So one of them is 19 and 2/10, but I have 4 of them, so I need to multiply that by 4. Now, for those of you that are getting a little stressed out that I did not divide by 2 for my base times height divided by 2, remember what I did. You can take one of your numbers and divide it by 2 at the beginning and make it a little more efficient. 3 and 2/10 times 12, and then that cut in half is going to be the same as 3 and 2/10 times 6, which is half of 12. It's going to be half the amount. So that's why I did it that way. But now I'm multiplying the 19 and 2/10 times 4 because I have 4 congruent triangles. 4 times 2 is 8. 4 times 9 is 36. Put the 6 down, carry the 3. 4 times 1 is 4, plus the 3 is 7. 1 digit after the decimal in my problem, so 1 digit after the decimal in my answer. But now I need to add, because this is the 4 triangles, that's the square. So I'm going to come over here, and I'm going to go ahead and add my 10 and 24 hundredths. All right, we know there's nothing there. Nothing in 4 is 4. 8 plus 2 is 10. Put the 0 down. Carry the 1. 1 plus 6 is 7. Plus nothing is 7. 7 plus 1 is 8. That square pyramid has an area of 87 and 4/10 square meters. All right, moving right along. Let's talk about triangular pyramids. Now, I want to make something very clear when we talk about these triangular pyramids. We are going to be assuming here in this lesson today and on this video that these triangles are equilateral triangles. If you're not sure what equilateral triangles are, they're triangles that all 3 sides are the same length. So it's going to be kind of like the squares, in the sense that we're going to have a triangle base though instead of a square base, but since it's an equilateral triangle where all 3 sides are the same length, the triangles going up to meet at the point are also all going to be the same size. So we're not going to have different sized triangles. So height of base, length of base. For my triangle, it's a triangular base, so it's going to be base times height divided by 2. Well, the height of my base, the length of my base, that's going to be 8 times 5. Well, 8 times 5 is 40, but I have to cut that in half. 40 divided by 2 is 20, because if I do the 40 divided by 2, just to remember the zeros trick, 4 divided by 2 is 2. There's no zeros here to cancel out. That 0 needs to be part of my answer. So the area of the base triangle is 20 square inches. Now, a triangle has 3 sides, so there's going to be 3 triangles rising up to my point at the top. They're all the same area because it's an equilateral triangle at the base. It says that the length of the base, okay, is 5 inches. The height of the triangle is 11 inches, okay? So I'm going to be doing 5 times 11. This is just the height of the triangle at the base. This is actually the length of the base, the length of the triangle. So this is the length of all the triangles here. So it's going to be 5 times my height, which is 11. Well, that's 55, all right? But then I have to divide that by 2 because it's base times height divided by 2. So when I take 55 and I divide it by 2, 2 can go into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. Drop the 5. 2 can go into 15 7 times. 7 times 2 is 14. 15 minus 14 is 1. I can't end up with any left over, so it's going to be add a decimal 0, bring my decimal straight up, drop the 0. 2 can go into 10 5 times, and I know there's none left over because 2 times 5 is 10. So the area of one of those triangles is 27 and 5/10. But I have 3 of them. Excuse me. So 27 and 5/10 times 3. 3 times 5 is 15. Put the 5 down, carry the 1. 3 times 7 is 21. Plus 1 is 22. Put the 2 down, carry the 2. 3 times 2 is 6. plus 2 is 8. There's one digit that comes after the decimal in the problem, so one digit that needs to come after the decimal in the answer. So all three triangles combined that are rising up is 82 and 5/10, plus the triangular base, which is 20. Remember, decimals need to be lined up. If I want to, I can make that 20 and 0/100. Adding those, 5 and 0 is 5. Drop the decimal. 2 plus 0 is 2. 8 plus 2 is 10. The surface area of that triangular pyramid is 102 and 5/10 square inches. Last one we're going to do today, for once again another triangular pyramid. The height of the base is 4 and 6/10 meters. The length of the base is 8 meters. So we know it's base times height divided by 2. So I'm going to be a little more efficient. I'm just going to take this 8 and divide it by 2. That's going to be 4. And instead of doing 4 and 6/10 times 8 divided by 2, I'm just going to do 4 and 6/10 times 4. I want to think about those little shortcuts, 6th graders. 4 times 6 is 24. Put the 4 down, carry the 2. 4 times 4 is 16, plus 2 is 18. One digit after the decimal in the problem. So one digit after the decimal in my product. The area of the triangular base is 18 and 4/10 square meters. Now, it's an equilateral triangle again, so all three triangles have the same area because the triangle at the base, all three sides are the same. So the triangles coming up are all the same area. It says the length of the base is 8 meters. The height of the triangles is 12 meters. Well, I can just take one of these numbers again and divide it by 2 to save me some time. So I'm not doing 12 times 8 and then dividing that by 2. Once again, I'm just going to make the 8 4, and I'm going to do 12 times 4. That's 48. So 48 is the area of one of the three triangles rising up. But I have 3 of them. So I need to take 48 times 3. 3 times 8 is 24. Put the 4 down, carry the 2. 3 times 4 is 12. Plus 2 is 14. I get 144. So the combined area of all three triangles rising up is 144. Well, I need to add that to the area of my base, which is 18 and 4/10. If it's easier for you, go ahead and add a decimal 0 there. 0 plus 4 is 4. Drop the decimal. 4 plus 8 is 12. Put the 2 down, carry the 1. 1 plus 4 is 5, plus 1 is 6. 1 and nothing is 1. The area, or the surface area of that triangular pyramid is 162 and 4/10 meters squared. All right. Have a good day, 6th graders. We'll talk to you later. Bye.